Astronomers are still in awe of the James Webb Space Telescope, JWST, because of its incredible powers, which allow it to see details that were previously unattainable. New structures within SN 1987A, a supernova remnant that has been thoroughly researched since its spectacular explosion in 1987, have been recently caught by the telescope. Even if the most recent findings might not completely alter our perception of the cosmos, they still represent a significant advancement that will pave the way for more astronomical study and discoveries in the future. This ongoing exploratory expedition serves as a reminder that each new piece of information adds a crucial piece to the cosmic picture. Greetings from space theory. It's time to discover the amazing things that our universe has to offer. Astronomers from all around the world were quickly drawn to SN 1987A when it erupted in 1987 because it was the closest and brightest supernova seen from Earth in almost 400 years. Located in the Large Magellanic Cloud, a dwarf galaxy that is close to our own Milky Way, around 170,000 light-years away, it provided astronomers with a once-in-a-lifetime opportunity to learn about the star's life cycle. Since then, SN 1987A has been essential to our knowledge of star evolution, supernova mechanics, and the behavior of cosmic dust and gas following such a massive explosion. Recent James Webb Space Telescope imagery indicates a feature near SN 1987A's core that remarkably resembles a keyhole. The complex keyhole structure, which is shown in blue, is brimming with thick dust and clumpy gas that was violently released during the supernova's catastrophic demise. Even the near-infrared light, which the JWST is specifically built to detect, cannot pass through the thick layer of dust at its core. This leaves a deep, enigmatic hole at the center of the keyhole, implying that there are still unanswered layers of material beneath which the mysteries of this cosmic show may be hidden. An equatorial ring glows vividly around this keyhole structure. This ring adds to the supernova remnant's intricate design by serving as a waistline and joining two faint, hourglass-shaped outer rings. The star expelled debris tens of millions of years before it finally went supernova, which is where the equatorial ring developed. It is not a result of the most recent explosion. The intriguing thing about this ring is that it has hot spots, which formed when the shock wave from the supernova struck the ring. The high energy produced by these exchanges is what gives the hot spots their dazzling glow. According to NASA, these hot patches indicate locations where the shock wave struck gas that was released long before the star's devastating destruction and interacted with the ring's composition. Thanks to the JWST's increased sensitivity, scientists have now discovered additional hot spots surrounded by diffuse emissions that are located outside of the equatorial ring. These emissions reveal regions where the shock from the supernova is still interacting with surrounding material, offering fresh perspectives on the dynamic processes taking place in supernova remnants. The crescent-shaped objects in the debris field that the Hubble Space Telescope had previously missed are arguably one of the most fascinating discoveries made by the Webb telescope. The outer layers of gas released during the explosion are represented by these crescents, which add to the supernova remnant's eerie yet chaotic beauty. There's a twist, though. These crescents may provide an optical illusion due to our viewing angle, giving the impression that there is more material there than there actually is. This unusual effect serves as a reminder that, even with highly capable telescopes, our viewpoints can have an impact on how we perceive celestial objects. Many years of research and observation have not resolved the riddle surrounding SN 1987A, particularly regarding the neutron star that is thought to have formed in the aftermath of the explosion. Stellar evolution theories predict that a dense neutron star would have formed as a result of the supernova's core collapsing. Observations have not yet verified its existence, though. Is it concealed by a dense layer of gas and dust, or has something even more bizarre happened? In the upcoming years, astronomers expect to finally unravel this cosmic mystery thanks to the JWST's unmatched sensitivity and resolution. The James Webb Telescope has not only recently studied SN 1987A, but other star remnants as well. Another remarkable exhibition of a dying star in its last phases, the Southern Ring Nebula, was captured in stunning photographs by the telescope early in its mission. The Southern Ring Nebula can be seen with binoculars on a clear summer night in both the northern and most of the southern hemispheres, unlike SN 1987A, which is much farther distant at 2,200 light-years. Specialists from several nations with knowledge of planetary nebulae and related phenomena are working together on a joint project named ESSENCE, Evolved Stars, and their nebulae in the JWST era. They anticipated that because the nebula was in the telescope's field of vision, Webb's observations would yield important information. JWST's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, have revealed previously hidden fine details, providing astronomers with the clearest view of the Ring Nebula to date. Researchers were astounded by the photos' extraordinary detail when Webb initially took them. About 20,000 distinct clusters of dense molecular hydrogen gas make up the brilliant ring that gives the nebula its recognizable appearance. Each cluster is astonishingly almost as big as Earth. Subsequent analysis finds a narrow emission band associated with complex carbon-bearing compounds known as polycyclic aromatic hydrocarbons, PAHs, which scientists had not anticipated to be present in this environment. Curious spikes that radiate outward from the central star outside of this primary ring are structures that were hardly apparent in Hubble's vision but now glow brightly in the infrared. According to scientific theory, these spikes originate in the shadows of the densest regions of the ring, where they are protected from the powerful radiation of the star. This shield of protection enables molecules to condense and form, including new layers into the intricate structure of the nebula. The JWST has revealed much about the filament structure of the inner ring and around 10 concentric arcs in the outer portions of the nebula by observing infrared light wavelengths that are undetectable to the human eye. These rings were an unexpected discovery that may indicate a recurring mechanism. Why would there be concentric arcs like these? It is thought by astronomers that the fading star has a companion star orbiting it at a distance comparable to Pluto's from our Sun. It's possible that the companion's gravitational pull molded the outflow when the star expelled its outer layers during its last stages, forming the concentric rings that we see today. This hypothesis, put out by Cardiff University's Roger Wesson, would not have been possible to verify without Webb's superior sensitivity and spatial resolution. Beyond just being scientific facts, the observations of the Southern Ring Nebula and SN 1987A made by the Webb Telescope signify a significant progress in both human curiosity and technology capabilities. People have been wondering about the world for ages, and this curiosity has led them to create new methods of seeing into the cosmos. In an effort to follow a comet as it passed through the constellation Lyra, astronomers made the initial discovery of the Ring Nebula in 1779. It has since served as a reminder of both our ongoing quest for knowledge and the intricate cosmic cycles that form our cosmos. These new findings bring to light an amazing fact. Researching objects such as nebulae and supernova remnants can give light on the universe's past, present, and future. When the Sun eventually reaches the end of its existence in about 5 billion years, it might even turn into a nebula, though this will probably happen long after we have all disappeared. Reassembling the story of cosmic history becomes easier when we comprehend the last chapters of stars and other places. While it may seem strange that several photographs of the same nebula may show such a wide range of hues, Webb's unique method of cosmos observation is the reason for this diversity. Things at infrared wavelengths, which are invisible to the human eye, are captured by the telescope. The information is first transformed into visible light wavelengths by picture processors. Otherwise, the raw data appears black. Through the process of color coding, scientists are able to highlight characteristics inside the nebula that would otherwise stay obscured by darkness. There is a great deal of potential for future discoveries because the JWST provides some of the deepest views of the universe and reveals minute features of star remains. This telescope is changing our view of space by revealing secrets about black holes and tracing the rings of faraway planets. What other findings do you anticipate the JWST will make public next? Maybe it will reveal even more about the enigmatic laws governing the birth and death of stars. Alternatively, it might lead us to the meager indications of life in the atmospheres of exoplanets. In any event, we have only just began our voyage into the unknown. Come along with us as we investigate the universe. Remember to subscribe to Space Theory and leave your comments for more cosmic explorations.